Hi, this is Dr. Xu, teaching design of experiments for engineering research. In this video, I will introduce the hypothesis testing. In the last video, we have used this dataset of the material strengths. Now, another similar material has a mean strength of 16.85. Does the current tested material strength, which has an average value of 16.764, different than the other similar material? In this example, we know the sample average, and we want to compare this material to a known population mean of 16.85. So this other material, the strength population mean is 16.85. For the current tested material, we don't know the population mean. We only know the sample average, which is 16.764. And we want to know whether the current testing material is the same as the other material or not. The method we use to solve the problem is called hypothesis testing. There are 5 steps in hypothesis testing. The first step is state the null hypothesis and the alternative hypothesis. We will start from step 1. Look at the question. We know the population mean strength of another similar material is 16.85. And for the current tested material, we only know the average of 10 test strength, and the average is 16.764. And we don't know the population mean of the current tested material because we did not test all of them. What we want to test is whether the true test material mean, mu test, is different than that of the compared material, the mu compare. The first step is state the null hypothesis, H0, that mu test equals to mu compare, and mu compare is 16.85. The alternative hypothesis, HA, is mu test not equals to mu compare. One of the tips in this step is always write the null hypothesis as an equality. The second step is choose the level of significance, alpha. What we do now is we assume mu test equals to mu compare, that is 16.85. We can take 10 random samples, perform the strength test, and compute the average. And if we did this exact same experiment a bunch of times, recall that based on the central limit theorem, the sample average distribution is a bell-shaped t-distribution. So if we do the experiment, the average tested material strength should be a value in this range here. What if we get a value smaller than this value or larger than this value? If the tested material true mean is 16.85, it is possible getting a value smaller than this or larger than this, but the possibility is so low. We know that the possibility is represented by the shaded area here and here. Possibility of these two area is 5%. Once we get values smaller than this value or larger than this value, we can reject the null hypothesis because the chance of getting such sample average is so low, only 5%. What is the chance of us making a mistake of rejecting these null hypothesis? If the tested material true mean is 16.85, the chance of us making a mistake and rejecting the null hypothesis is only 5%. And we just say we accept such a low chance of making mistakes. The value of 5% is called the level of significance. It is represented by the letter alpha, and it is the probability of rejecting the null hypothesis when it is true. So 5% is a commonly used level of significance, but other values can also be used. For example, if the significance level is chosen to be 1%, then we will have an even less chance of incorrectly rejecting the null hypothesis when it is true. Because the chance of a significance level may change our conclusion, it should be determined before we seeing the data to avoid biased judgments. The third step is to find the critical values. In this step, we will find the values corresponding to the significance level we have chosen. So the significance level is 0.05. That means we want this area to be 0.025 and this area to be 0.025 as well. We need to find the t-values over here and over here. By using the table on the right, we can find T2 first. So the area is 0.025 here. And we have 10 samples, so the degree of freedom is 9. And we look at here, we get the t value of 2.262. Because the t distribution curve is centered at 0 and the t value, so the t value at the left is negative 2.262. The fourth step is to find the t-value of the sample average. In this step, we calculate the t-value of y bar. If the t-value is less than or equal to negative 2.262 or larger than or equal to 2.262, we reject the null hypothesis. This is because if mu test equals to 16.85, the chance of getting a sample average in this and this range is so low. Therefore, it is not likely that mu test equals to mu compare. To calculate t, we use this equation. T equals to the sample average that we are calculating the t value for minus the population mean. In this case, it is the null hypothesis value of 16.85. So equals to 16.764 minus 16.85 divided by the sample average distribution standard deviation, sigma y bar. Sigma y bar can be calculated by using the population standard deviation sigma divided by the square root of the sample size. But we don't know the population standard deviation, so we use the sample standard deviation S as an estimate for sigma, and S is calculated using this equation. In the previous video, we have calculated S equals to 0.316. So sigma y bar equals to 0.316 divided by square root of 10. This is because we substitute S to sigma equals to 3.16. Now we have got this value and we calculate here this t equals to negative 0.0272. The value is somewhere here, negative 0.0272. Because the t value in the middle is 0, it's only slightly less than 0. It is not within the two rejection regions. So we fail to reject the null hypothesis. This means if the tested material strength population is 16.85, it is quite normal to find the sample average of 16.764. Thus, the finding does not support the alternative hypothesis that the tested material population mean is different than 16.85. The last step is to draw the conclusion. Because the calculated t-value is not within the rejection region, we fail to reject the null hypothesis and we don't have strong evidence that the tested sample average strength is different than the compared material strength of 16.85. In this example, we only care about whether the tested material is different than the compared material or not. We don't care about whether the tested material strength is larger or smaller than the compared material. This is called two-sided hypothesis testing, because if the tested t-value falls in the region on the left or on the region on the right, in both scenarios, we would reject the null hypothesis. In the previous slide, we have calculated the t-value of the sample average and compared this t-value to the critical t-values here and here corresponding to the significance level. If the t-value is less or equal to the left tail t-value or large or equal to the right tail t-value, we reject the null hypothesis because if the null hypothesis is true, we only have a small chance of getting t-values in these ranges. Alternatively, instead of comparing the t-value, we can calculate the probability corresponding to the sample average and compare it to the significance level represented by the red shaded area. In this example, the sample average is 16.764, and it corresponds to the t-value of negative 0.0272, and it is here. So the chance of getting this value or less is represented by the green shaded area. But it does not make much sense to compare a one-sided area to a two-sided red area. Because the t-distribution curve is symmetrical, what we do is calculate the probability of the two-sided area. So on the right, symmetrical to the t-value equal to 0, on the right, at t-value of positive 0.0272, we calculate this area as well. And we compare the total area of this green shaded area with the significance level, which is the probability represented by the red shaded area. So this is the two-sided hypothesis testing. We can find the p-value using the t-distribution table. We know the degree of freedom is 9 here. This table is right-sided, so we'll find the area on the right first, this area. And this value corresponding to a t-value of positive 0.0272. These are the t-values, and these are the area there. When we look at the numbers 0.0272, it is too small and it's not on the table. It should be on the left side of here. If we have a complete t-distribution table, we should find the values on the left here, and then we can find the area from the table. If this area is A, because the curve is symmetrical, and this area is going to be A as well. So the p-value equals 2A. And then we compare this value of 2A to the significance level of 5%. As we can see here, as the t-value decreases, the area increases. So what we know is A is definitely larger than 0.1. So 2A is definitely larger than, here is 0.1, 0.2, and this is definitely larger than 0.05. Therefore, we fail to reject the null hypothesis. Many computer programs can calculate the exact p-value. I will show you how to do it using an Excel spreadsheet. In an Excel spreadsheet, put in the command equals to t-dist. This is used to calculate the p-value from t-distribution. And then parentheses. In the parentheses, there are 3 parameters. The first one is the t-value. You have to put the positive t-value. So in our example, it is 0.0272, comma. The second parameter is the degree of freedom. In our example, it is 10 minus 1, that's 9. And the last one is the tails. See here, one tail distribution or two tail distribution. If we select one tail, it will return the area on one side. The area on the other side is the same because the curve is symmetrical. In this example, we want to know the area for both tails. So I can select here or put 2 here. Enter. The return value is 0.979. This means the area here plus here, the area here plus here equals to, so P equals to 0.979. This is larger than 5% of significance level. We fail to reject the null hypothesis. Similarly, to draw the conclusion, because P equals to 0.979, which is larger than the significance level of 0.5, we reject the null hypothesis and conclude that we don't have strong evidence that the tested sample average strength is different than the compared material strength of 16.85. In summary, in this video, we have talked about the hypothesis testing. There are 5 steps in the hypothesis testing. There are 2 ways of drawing conclusion. One way is we calculate the t-value of the sample average and compare it to the critical values corresponding to the significance level, or we can calculate the p-value. If p is less or equal to the significance level, we reject the null hypothesis and conclude that there is sufficient evidence that the average is different than the null value. If the p-value is larger than the significance level, we accept the null hypothesis and conclude that there is insufficient evidence that the average is different than the null value. Thank you very much for watching. This is Dr. Xu. I will see you in the next video.